Welcome to the Meltzone podcast. This is episode 57. I'm Tom.
And I'm Stefan. And on today's episode, we are... What did we start? We started talking about Tom's new, workspace shop that he is currently putting an office space in there and will move his studio to soon, which is really interesting. And I kind of envy him for that. Then we talk about a recent topic that came up with Tom's review of the Form 3 Plus and my Mechanica Evo CNC router. And this was the question if we should even review Pro Tools, because we got kind of a lot of negative feedback on the machines because they were too expensive from a maker perspective. Speaking about professional or semi-professional machines, Tom was recently asked to do a review on a Markforged 3D printer, which he already did a couple of years ago. So probably he rejected. But staying on the topic of Markforged, in the past, they, were very popular for their nylon materials, carbon fiber nylon materials. But they started introducing PLA on their machines, which is really expensive. So what could be the reason for that is something that we are going to discuss.
Yeah, by the way, if you guys would like me to revisit the Markforged machines, leave a comment below on YouTube or tweet at us. Stefan shares a success story with his macro photography setup, where he shared some really amazing pictures on Twitter and Instagram. So check those out there after you watch this episode. And he shares a failure story about his Volcano nozzles. And, we get into how you can even test a product for all the different things that users are going to do to them. Speaking of users, Quinley Vision has released their 3D printle that they're calling a Wordle for 3D printing users, and we get into the weeds of machine learning AI, how you can sneakily generate training data for that. And finally, a question from you guys about thermistors versus thermocouples versus resistive temperature sensors, and why we're still using thermistors when they're not that great of a choice. Maybe they are.
You got a new place? For not living, but working.
I did. Well, new workplace. Are people excited about that? Yeah, I finally got a proper studio space. I've been dreaming of this for so long. And this is it. I almost missed it. It was just like a eBay classifieds, Kleinanzeigen, ad where it was like, here, I'm renting out this warehouse space, 100 square meters, 1,100 square feet, a foot. It's got like a semi-floor, floor heating. Yeah, and I was like, okay, well, this can't be that bad. And it's right around the corner, so let's have a look. And it was literally the perfect place. It is nice and insulated. It's the right amount of space. It's got extra storage space up ahead, above head. It's got an extra floor that you can store stuff on. I've already built an office in there. And that office is also going to serve as my studio backdrop. And basically, I've got a 6.5 by 6.5 meter square. That's going to be studio space. That's going to have like 2 or 3 sets. And I got everything plotted out in my head already. Right now, it's a construction site. Because I did stick frame in that office space myself, and I did the drywall and painting, and now I'm putting in a drop ceiling, and it still needs a floor. I'm doing all that myself. I'm very much enjoying the process of getting my hands dirty, of working on something physical. I always find that rewarding. I think I've talked about that before, but yeah, lots to do. Lots of my time that I'm putting in there, but it's going to be so sweet once it's done. I had that. This is it. This is the dream moment today when I had like I've just got like the drop ceiling light sitting on the wall right now, leaned up against the wall. Had the music blasting outside and in the open space, and walked out of the office and was like, yeah, this is it.
No, I really envy you for that. To be totally honest, this would be something I would want for myself. Just the vast open area, the possibility to have, as you just said, different sets. You can have different projects going on in different like corners of the room. You don't have to clean up all of the time because you can work on that stuff.
Probably still should.
Well,
yeah, but I now have the space to put like a CNC router or a manual mill or a lathe or stuff like that. I've owned a TIG welder for a while, but I've loaned that out to a buddy because I don't have the space to put it anywhere. So that's been living with them for the longest time, and I can finally get it back in house and use it. And it's just it's so much space for activities, as they say.
And you don't, it's as it sounds, you don't have a neighbor where you have to be super patient that you're quiet all of the time. Because I was also looking for an office space, and they told me, yeah, we would like that. There are other like companies and people there who would like that to be really quiet and stuff like that. And I said, oh, I don't know if that's gonna work out all of the time.
Yeah, so it's not an office space. It is an actual Halle, a warehouse. It's basically just 4 walls and a roof. And I share that building with my landlord. So the building is like 10 by 20 meters, and the back half of the building is where my landlord does his stuff. And there's a solid wall between us. Well, if you can still hear each other through the ceiling, but it's not bad. Like if I run a router or something, it's not going to bother him because he doesn't do any recording or stuff where like absolute silence would be critical. And also the good thing is he doesn't have a business that is noisy either. So perfect for recording. And it's a freestanding building. It's not like an office complex or something. And yeah, if you hear a bit of noise outside, it's not going to bother anyone.
Yeah, and it is a warehouse, but it still has like floor integrated heating, which is something that just makes living and working there way more pleasant. If you have your small office in there, it's not gonna feel that much different than like being at home.
Absolutely, yeah. So I've got a little window to the outside of the studio that I put in. Well, it's around the corner. You can, I mean, that would be the studio backdrop, but it's really gonna be sweet.
Cool.
And it's not that expensive. I mean, it's a fair price. It's a fair deal that I got. It's close enough to me that I can ride my bike or even walk the dogs there. So that's perfect. Yeah. So far, unless I find like that, what's it called? That one thing that stands out and that's bothering me, I think this is going to be really sweet. So
cool.
Yeah, I've been working just physically construction, doing all that stuff, getting everything ready, and hopefully by the end of the month I'll be moved over there, and I'll be working from there.
That's a pretty tight schedule.
I mean, when did I start? So end of February basically is when I started like the construction stuff. So I'm redoing all the electrical. I'm building that office in there. That is almost done now. Just need to put in the drop ceiling. So electrical I still need to mostly do, and then just moving everything over. So that's basically, I've got one more video to make next week, and then I can move over and spend my time on that. So should be done by the end of the month, I hope.
Well, you have been moving out of your old space 1.5 years ago, 2 years ago,
something like that. Yeah.
So there's probably not going to be that much stuff you find in your studio now where you think, oh yeah, there's still like 5 printers from GearBest. I didn't know I put them there.
I mean, I think I still have like 1 or 2 printers AlphaWise or something in their boxes. I don't know. Joe just found one. He found the U30 in the box. I don't know. So I'm not going to be moving everything over there right away. So I'll still keep, the workshop, which is my personal workshop, basically, the space that I've started filming stuff in many years ago now. And I'm still going to be able to use the space here in the basement. So I don't have the pressure to move everything to the new space immediately.
But I guess this is also one of the good things, because then you still have your personal shop again at home, and you can use it again to work on stuff that doesn't go on video. That's just for either your own pleasure or just because you need to do it at home. And again, you can leave your stuff there. There's not the necessity to put it on the side that you can continue working on a video where everything needs to look good and nice and stuff like that. Yeah. So I guess this is something which is really nice, also like separating work and living and just being at home again.
Absolutely. And I fully understand that this is an absolute luxury situation to be in, having the space at home to have a workshop and a studio space and a dedicated building that I can run my YouTube stuff out of. I guess not everyone's watching from Patreon and supporters, but like, thank you guys for making this possible. This is a dream come true for me, basically. And hopefully it's going to be, I mean, the goal, of course, is to have the option to do more content, to hire someone finally, to help me produce more stuff. It's kind of like, that the pressure's on right now, because it's like, I've been dreaming of this for so long, and now it's like, I have to make it work. I have to move on this, but yeah, super exciting times.
Cool. Yeah. Envy you on that. Maybe just to get this to close, I was also looking for a space, and there's currently an old like industrial site being renovated, like just 1 kilometer next to me, because there is the Landesgartenschau, like the I don't know, state garden exhibition, something
gardening basically.
Here in 2 years, and they're renovating those really old industrial complex, and they're also putting like new offices in there. But there was one free 80 or 90 square meters, but they were asking like around $1,500 a month for that.
Okay, that's pretty steep.
That's pretty steep. And then there's the thing that like a workshop in the basement would have cost extra, that they wanted to have quiet neighbors. There were really big glass windows all around the office, which is not super great for like production work. Yeah. So I don't know if I will regret in the future not taking that deal, because the office itself would have been like really nice and just like a kilometer from where I'm living. But on the other hand, like just spending $1,500 on
a space that's already limiting you, like
exactly. It's way more than we're paying in the house where I'm currently living at.
Yeah.
But yeah, I hope that something else will pop up in the future.
Yeah, maybe there's just going to be something that clicks, like it was for me. It was like, there it is, totally inconspicuous listing, and it was like, it's the perfect place. So,
no.
And I was waiting for this thing for like 4 or 5 years, so like, finally.
Yeah, finally.
Sometimes stuff just clicks. So let's move into some topics, shall we?
Yes.
Well, after we finish this banger of a first topic, I'm so excited about this. But yeah, you put in a big topic for this week that has a bunch of facets to it and a bunch of different angles that we can explore it from. And you just put in there, should we even review Pro Tools? What is that all about?
That is all about, I guess, your recent review of the Form 3, which is a Form 3 Plus, which is $5,000, $3,000.
I already forgot. I think it's like $4,500 for the machine, including VAT.
Okay, $4,500.
But of course, the washing and curing stations are like another 1,600-ish on top of that. So like $6,000 for the setup.
It's an expensive SLA 3D printer.
Pretty much.
And I recently reviewed I would put it a semi-professional CNC router. And I kind of got a lot of hate, or not me personally, but people were complaining that the machine is way too expensive for what it is delivering, because I think my and also your audience is mainly makers for whom price is a thing they're thinking about, and most of them would rather either build something from scratch or buy something cheap and just improve it that it properly works. So paying like $3,000 for a CNC router, which doesn't have linear rails and ball screws and things like that, seemed to be way too much for lots of my viewers. But the thing that the company, Mechanica, is offering is that the machine properly works when you assemble it. It is easy to assemble. It has a proper certificate of conformity.
Right.
They provide a ton of tutorials and just background information to make the thing being usable very easily. And for someone who wants to buy a tool in order to make a product with it, and probably maybe doesn't have that much experience with CNC routing or CNC in general, a product like this, even though it's way more expensive than DIY solutions, is, in my opinion, still worth the money. And I was kind of feeling bad for Mechanica at that moment, because they said, oh, they're seriously upset because they have put so much effort and heart into that product, and now they're getting comments like, this is way too expensive, this doesn't have a basically a place. And I wondered if you got kind of the same comments on the Form 3, because I think it goes in the same direction.
Yeah, I mean, absolutely. Same comments. But it's always when there's like a tool that costs more than, let's say, the average or the lower end alternatives. It's always that same reaction, like, hey, my printer can do the same at a fraction of the cost.
Yeah.
Quite often it is, hey, my upgraded Ender 3 can print just as nicely and just as fast. And I'm like, sure, yeah, absolutely. But like, you're kind of missing the point. So I took two notes here that while we were talking, I was actually skipping over stuff. You were saying our audience is maker and low cost and DIY focused, but I think it's just that is a larger audience, right? That there are more people there that in the absolute scheme of things, there are more people that are able to get into low cost stuff and want to tinker with that and have a bit of extra time to spend on that. Then there are people actually using a product for its intended purpose for production. I should turn on this extra light. Sorry. For like the absolute exact use case that somebody like Formlabs is looking at. That was the other thing that I was noting down. The Formlabs Form 3 Plus is not the best resin printer. It is like, it doesn't have the crispest prints. The resin is hellishly expensive. And it's slow. It's just, if you just take the specs, it is not a good printer. But if you take the experience, it's a much better printer. It's not perfect either, but it's a much better overall experience than like a Mars or something like that.
Yeah.
Just because you get the no, you don't have to handle resin as much as on other printers. You don't pour out a bottle. You just have the cartridge. You have the tank that you can easily replace resins with, which you can technically also do on other printers. The interface is like really dumbed down, really simplified. It's just that even the choice of using a laser versus an LCD, I think is at this point in time is purely because they've got the laser under control and they know it's going to last. An LCD it's more fragile. It's going to wear down. I don't know how long exactly an LCD is going to last. I've not worn one down yet, but I have cracked one, which probably wasn't its intended use case. Yeah, I was shoving like fibers in there, so like, okay. But yeah, it's just it's a different trade-off, right? It's a different trade-off of features versus performance versus usability. And if you look at price, and I think that's something I mentioned in the Form 3 Plus review too. the fact that you don't have to train someone on the machine. If you're looking at a business case, if you're looking at a use case where you put this thing in a company, in a corporation technically, and use it for profits, you use it for producing something that you either wouldn't be able to do otherwise or would do in a fabrication shop, then the fact that you don't have to train people on using it, it's going to save you so much money. And the machine price at that point is completely irrelevant. The $4,500 plus the $1,600 for the washing cure, doesn't matter at all. That's if it saves you 2 or 3 days and you have 10 users, it's already paid for itself.
Yeah.
So that is the value proposition there. And I've tried to focus on that with my review videos, just like pointing out, hey, this is why this is different. And I think I got the point across somewhat, but it's still, of course, it is still hard to explain to an audience that is used to just getting everything at a bargain cost, but also having to invest lots of their own time into getting stuff to work. Yeah. I'm not saying that every product is like that. There are definitely some good ones that don't require any futzing and they just work, but there's always a trade-off.
Yeah. But in the end, getting this negative feedback from the viewers, I have been asking myself if I should accept similar products in the future, where I know that 99% of my audience won't be buying it and can't be buying it because they are not the proper target audience. Is it still interesting for them to see what can be done on professional machines, what professional machines look like? Or isn't it really interesting for the big crowd? And does it maybe even harm the company that is giving you the professional or semi-professional machine to review, or is the exposure enough benefit for them?
I guess it's gonna really depend on how you do the review. If you like I tried to, if you say, hey, this is a tool for this application and it's good in that, and it's good or bad in the intended application, then I think that's what they want, right? That's what's fair to the product. If there is such a thing as an application where it's actually good in. If it's a piece of crap that's just overpriced, that's a different story. But I don't know, if you compare it to an inferior product and you're just going, okay, well, this isn't better or that much better. Or if you leave out all the stuff that is unique to a product, that's always what it comes down to, right? It's the exact opposite of, as far as the review process goes, to reviewing an Ender 3 clone. With an Ender 3 clone, it's oh yeah, it's got this feature and that's built well and that isn't, so we can directly compare it one Ender 3-ish machine to another. With something that is its own little bubble that you don't have anything that you can directly compare it to. It takes a lot more effort to review. It takes a lot more effort to be fair to the product and to get that across. And I find it hard too to make a recommendation for or against a product when it's just it's a more unique thing, right? So
yeah, I will be definitely thinking about that fact next time a company is approaching me, because I don't know, I think it's going to be bad for me and for the company if the product is crap and, well, they are not giving the user any benefits on paying that much more. But if there is the advantage of usability, I don't know, a warranty or support they're getting, or whatever, and it makes the product worthwhile for a specific application or user, I guess it still might be interesting. But it is really hard, and I haven't thought about that fact that much in the past. But it just, I don't know, it it was also a bit, it hurt also. It hurt a bit to hear from the company themselves that they feel so bad about all of these negative comments. And I tried to explain them that I have basically expected them and they should not feel that bad about it.
Well,
for once, it's the internet.
Yeah.
For once, just my audience and their target audience, there isn't that much intersection, but there is still a bit of intersection, which I think still makes the review worthwhile for this small group.
Yeah. Well, so my experience with like, as far as like interest in stuff is, you know, the pro stuff rarely gets the same amount of attention as like a solid, affordable option. What to compare? I mean, we've got Markforged here as one of our next points. I think Markforged got a lot of interest because they were unique. What else? There was something that was where people were really interested in, and the video did really well, but it was not something that was even in the like range of attainability for like your average user. So sometimes it works. Sometimes it's just the product is just that good. But most of the time, pro level tools on on my channel at least, and I think it's similar for you, doesn't get the same amount of interest as far as views goes. And also earnings wise, if you're taking a look from the money perspective, is it worthwhile for us to do them? Well, if people aren't buying the products through affiliate links, as you know, would be a really easy way to cash in on like hyping up an Ender 3 Pro S Plus, it's just not going to happen, right? First of all, you're not going to find. I found like one affiliatable link for the Form 3 through iGo 3D that I could put up, but yeah, nobody from the audience is going to be buying that, and especially not through links up. Like we're not earning anything on those reviews, except for ad revenue and sponsors. So it's from a monetary perspective, it doesn't make sense. But what you pointed out, like, is it still interesting? I find it interesting to see like what else is out there. For me personally, I really enjoy that little look outside of our tiny dessert bowl that we live in, and just über den Tellerrand schauen, right? That's what I find interesting, though. Like I said, the videos that get produced from that don't tend to get the best response. Like, yeah.
So maybe you just teased it, your invite for doing another Markforged review. Can you talk about that for a bit?
Yeah. Well, there's not much to talk about. So if you enter into the Google search engine, Mark II review, one of the top hits is, I think it's going to be like hit number 1 or hit number 2. You're going to have the YouTube link to my video from 5 years ago where I review the Markforged Mark II. For those of you who don't know, Markforged makes machines that inlay. Oh yeah, I can hear it in the background there. Markforged makes machines that inlay solid carbon fiber strands into, or continuous carbon fiber strands into nylon. So either into like PA 612, I don't know what they use, or a chopped carbon fiber reinforced material. They're calling Onyx, which is also nylon based, and they just insert. They have a second extruder head that inserts like a nylon coated carbon fiber or Kevlar or whatever you want to use, and that's what they do. That's their thing that the machine is built for. And they reviewed the Mark II, which is their flagship. Or I don't know if the flagship, but it's like their bread and butter machine. Basically, it's a really well built machine. It's incredible to look at. It is nicely made. And it is incredibly expensive, as we talked about with these pro tools. It's very expensive. It's a nice printer, and it does the job well. It makes very rigid parts, and yeah, they wanted me to review it. Their agency did. So their agency sent me an email. Hey, we've got this cool product from Markforged. Would you like to try it out? And I was like, dude, like, use Google. Come on. Yeah. So I'm not reviewing the machine because it's the same machine.
Okay.
A lot of people were like, "Hey, take the money and just do it." I was like, "What money?" I guess, like I just talked about, there's no affiliate money in it. The videos typically don't perform well. I don't get paid to do reviews by the companies, only by the sponsors if somebody's interested in that. But yeah, there's no.
And if you're not keeping the product and use it for your benefit, or if you can sell it afterwards, it's a lot of work for not that much gain.
Exactly. Yeah. So I did send the original Mark II back that I reviewed, as I will with the Form 3 Plus. So yeah, there's no the thing. Maybe one last point with those pro grade machines. If it's a locked ecosystem like it is with the Markforged machine or with the Formlabs, I should really put these fidget PCBs aside. It's not a machine that I would be interested in keeping and in using, actually, because, well, using them is expensive, and I think I have enough training to use a machine that gives me the same or better results with less monetary investment. Let's put it like that.
Mm-hmm.
Because typically, we don't get like a consumables flat rate with the products we review or we get to keep. It's not like, hey, here's an Anycubic M3 Plus, and by the way, if you ever need any resin, yeah, just reach out and we're gonna send you like a 20 kilo package. No, that's not how it works. If you need some stuff, usually the companies are fine with it, but it's not like we just get a flat rate, especially not with the more expensive consumables with Formlabs or Markforged.
Yeah, and
I'm talking lots today. Sorry about that.
Yeah, you're talking a lot. I'm already a bit tired, so it's already late in the day. So I hope you guys don't really notice that. Yeah, and I guess if your viewers in the end want to replicate things from your projects and you're using materials and machines that they don't have access to and they maybe don't even compare to the machines that are otherwise on the market. For example, the Formlabs printer. This might make your videos worth because, yeah, as I said, they are not as easy.
Yeah.
Reproducible. Yeah. Whatever.
Yeah. So if you use like the what is it called, the something 10,000 or whatever resin from Formlabs, that's glass fiber reinforced. I've not used it. They just sent me 2 of their standard gray cartridges, which is a bit of a shame, but I only have 1 vat either. But it is what it is. From what I've read, the parts with that glass fiber reinforced resin are crazy strong, and it's an actual engineered resin as opposed to like the glass fiber experiments that I did. So yeah, if there's a project that I do that requires that resin, and if it's a project that invites replication by users and not something from stuff made here where the thing's going to kill you if you use it wrong, then yeah, that makes the project itself less attractive, right?
Yeah.
Yeah, don't want to ramble on that too much. But to get to the next point, Markforged now introduced PLA.
Yeah,
they discovered PLA for the machine. I mean, okay, we're laughing here, but it's the same thing, right? It's a usability thing. If you already know the machine and you just want a cheaper filament at 64 euros per kilogram, and you want to keep using your Markforged printer for that, then you now can. They now sell you PLA that works with the Markforged printers.
I tried to check it, and I haven't found that Markforged was selling any other, how are they calling it, precise PLA, if they were selling unprecise PLA before. So I guess, yeah, I think they have for once seen the necessity to make their printers usable with less expensive materials that might even give you better printing results, like nylons, for example. And also just a market there, because if they can sell their precise PLA for 64 euros a kilogram. I think there's quite a bit of a markup on those rolls.
Easy money.
I guess you said before that in the past they said that their hotend and their extrusion system might not be made for PLA. Either if it's because
don't know about that
heat creep, either if it's due to, I don't know, they have kind of a closed printing chamber.
It is enclosed, but I don't think it is heated though. I don't really remember.
It's probably not actively heated.
It's been 5 years since my review. Sorry about that. It is definitely being heated by the build platform, which is just a slab of aluminum.
Yeah. And this makes, well, the hotter the environment is, the harder it is to print PLA. So there might have definitely be some reasons why PLA was not a material that worked well on their machines.
I don't even know if it has a part cooling fan.
Part cooling fan.
Yeah.
Exactly.
Because the nylons don't need it. So it might actually be a special formulation of PLA that's, you can get the different NatureWorks grades that does not suffer as much from a lack of part cooling. So.
Yeah.
Though, this does look like a part cooling fan, to be honest.
It does look like they have a part cooling fan. On the one hand, for the consumer, I find it kind of good that they're integrating PLA in their slicer and everything, because I still have the opinion that printing PLA has definitely its place, not only for visual parts, but there are even some mechanical applications where it can be used if the conditions are right.
Absolutely.
And in the end, I'm quite sure if you're comparing the print quality of parts from PLA to nylon materials, I think PLA will be better. Maybe you probably can even print it faster, so you can faster iterate on your projects. So why not try either really to tweak a material that it works on your machine, or just to tweak the process that the machine can use that material?
Yeah.
I don't know how locked up the system is. So if you can just feed the printer with non-Markforged PLA.
I don't remember. It's been too long.
Well, things could have also changed over the last years. So I find it kind of good that something like this is happening. This reminds me quite a bit about a machine that we have at work, which is like a really nice 3D printer for printing ABS parts that can be more or less like 0.5 meter by 0.5 meter by 0.5 meter in volume. This machine was designed with a heated chamber to print huge ABS parts, and it's doing that job very well. But I guess 2 years after we bought the machine, they started introducing also PLA on their machine, because I guess they also had a bunch of customers that wanted to print PLA due to, I don't know, more colors available, nicer print quality and things like that. But they, for example, had to add a part cooling fan. They had to make sure that their closed and isolated chamber is well ventilated to keep the temperatures low. If you have a print bed that is 0.5 meter by 0.5 meter, it gets really toasty in that chamber, even if you only have 60 degrees on the bed. But they also seem to have made it work. And for us as a company, it has the benefit that we're now able to print bigger parts, which I find kind of nice.
Yeah. I just looked up the DRM and lock-in on Markforged, at least from my review, which was internal number 114. I'm now at 353. I crossed 500 videos on the channel recently. So wow. Oh, and
400,000 subscribers.
Yes, thank you. I always miss these milestones, and then I'm like, well, maybe let's do like a multiple of 2. Or what's it called then? Potence 2.
a power off.
Yeah, let's do power of 2 just to make it look like that was intentional. But yeah, I totally missed that. But yeah, the Markforged printer, at least when I did the review 5 years ago, did not have any DRM or cartridge system or chipping or whatever. So, quote, while there's no DRM or cartridge system keeping you from using other filaments on the Markforged machines, and you could even use Markforged base materials on other printers, as it's just standard 1.75 millimeter size, they still heavily advise against using third-party materials, especially when using it with continuous fiber. So that's maybe a bit of an asterisk. Asterisk. You are not going to be able to use continuous fiber reinforcement with PLA, I believe, because it's coated with a nylon that makes it compatible with the Onyx and with a nylon, and I doubt that would be compatible with PLA.
Yeah, but
yeah, I guess you could use just standard PLA on the machine now. So, bravo!
Congratulations.
Unless they added some DRM, which I don't think they did.
Okay.
So we covered the topic in all its extensiveness. So let's maybe scale it down a bit, or scale it up, as you did with your macro photography approach.
Yes.
So
we can probably now do our thumbnail shot. No, there we are.
what
Yeah.
if we can get in focus.
There you go. That is my.
There's the thumbnail.
That's my $20 like macro lens, which is a cheap 10x microscope objective on a 160 millimeter tube with an L mount adapter that screws to my camera.
Okay. So it's a microscope lens, just nothing special. The same thing you would put on an extra microscope. Question for me: is there any active optical element in there except for that lens?
No.
Okay.
It's not.
So basically, all you're doing is you're adjusting the flange distance, and that's it.
Exactly. Maybe to do a bit more of an introduction to the ones who are not following me on Twitter and on Instagram, I have been loving macro photography and just working at microscopes for many years. But like a month or two ago, I got into some kind of a rabbit hole and watched a bunch of videos on macro photography, and I thought, okay, I want to dig deeper in that, because it was always interesting for me to take an in-depth and detailed look on 3D printed parts, or on, I don't know, cut up nozzles and things like that. So yeah, I started playing around, and I noticed that, well, I do have a macro lens for my other setup, which is a 30 millimeter Panasonic, which does a really great job. But I always lacked a bit the amount of magnification. So I did a bit of research, ended up buying at first a new camera.
as one does.
As one does. I bought a full frame camera. I don't know, somehow just to use this mic.
Yeah, honestly, full frame doesn't. I mean, if you're going for maximum magnification, I think the smaller sense would actually be better, because you're cropping in essentially.
Exactly.
If your lens can handle it, if your lens can produce enough detail for to cater for that crop.
Yeah. So I was looking for commercial or commercially available microscope lenses for cameras, and there isn't actually a ton for the micro four thirds cameras that I use with my GH5 and my GX80 that I've been using over the last years. So I have found this Laowa 25 millimeter 2.5 to 5x microscope lens, and I bought the suitable camera body with it, and it enabled me to really use my camera as a microscope. The thing is, with these lenses, the depth of field that you're getting is really, really shallow, sometimes only a couple of micrometers.
Yeah.
So what I also had to do is I have a macro sled. Is it called macro sled? I think it's called a macro sled. It's basically a mount on which I can put the camera, and then with like a thumb screw, for example, move the camera in short intervals closer to the object. And then you can, at each of the iterations, you make one picture, put them into a software. The software is calculating from each picture the section of the picture that is sharp or which is in focus, and then it's creating one picture where everything is in focus. And that was really nice. And of course, I wanted to go even deeper or even closer. And yeah, I did even more research and browsed around and read a couple of things. And people were just suggesting using cheap microscope objectives. And
lenses.
They have a focal length of 160 millimeters. So if you put them 160 millimeters,
that is
away.
That is quite. So is that something that is specific to that 10x magnification lens, or
no? It is not. 160 millimeters.
Oh, hold on. So not focal length, but like focus flange distance sensor.
It's flange distance. It's Brennweite. Is it? I think it's is it? You have to mount them 160 millimeters apart from your sensor to get a sharp image. It's the standard for, I wouldn't say all, even commercial microscopes, but it is a standard that has been around for 100 years.
Okay. So at that 160, more like that, at that 160 millimeters, either you have your sensor, if you're mapping your image directly onto an image capture device, or you have some sort of eyepiece that creates that transforms that focused image back into a reales imaginarias, whatever that's called in English.
Something that you can see with your
that you
eye.
Can see with the eye, because your eye is basically another camera. So
exactly,
106 millimeters. Okay,
and that works really well. So of course, on a podcast, you can't show pictures that well, but if you guys are listening and want to see a couple of really interesting, I don't know, just macro shots of cold pulls of broken carbon fiber reinforced materials, check my Instagram or my Twitter. I still love it. It's such a rabbit hole I fell in, and I just love taking these detailed looks on parts. And of course, I invested quite a lot of money for the camera body and the Laowa lens. But if you have a DSLR, this thing is $20. Of course, you should get the lens adapter, but
though
in the end you could also 3D print that. But I didn't want to.
One of those adapters, I got like an extension tube adapter that's basically just the lens mount plus like some fine thread, fine pitch thread. Those are like $10, right? Yeah. Or if you get like just if you want the metal mount to mount it into the camera, you can also get like an L mount in your case to whatever Canon FD or something, and glue in your printed extension tube. So that's not a huge investment. And honestly, like you said, if you have a DSLR or any DSLM, even mirrorless camera, anything that you can mount your own lenses onto is perfect. In fact, the camera that I have as my main camera, the A7S III, is probably one of the worst cameras for it, because it has a huge sensor, so you don't get much magnification, and also it's only 12 megapixels, so you can't really crop into it much. So what I've thought about is actually using my actual microscope camera that I have, which just happened to be like a microscope camera, but it's just a 4K 60 camera with an HDMI output and a USB port that you can save like captured images onto. That's my starting soon camera for live streams. That's like completely out of focus. And it has a tiny sensor. It has like a 1/3 inch type sensor or something. So that would really crop into those images. Maybe have to do some experimentation there too.
Yeah. So yeah, for the future, I really want to make a video on that topic. I am still, so what I'm currently doing, and some members of the community are helping me out there. So the macro sled that I made, I started like really turning the thumb screw manually. But if you need to do 200, 300, 400 shots of a part, this takes a while. And the thing is that any teeny tiny amount of vibration that you're getting will screw up your images. So what like the pros are using, they're using motorized camera sleds, but they are starting at around $500.
I've got one of those, but it's not a particularly good one. Idea. I've got like a...
Just put... You could even put it on a 3D printer.
Yeah, exactly.
Yeah.
So just put it on the bed.
Yeah, put it on the bed.
Use it with Octoprint, Octolabs. There's probably a G code to trigger the shutter on a camera with either cable or infrared or something. Do that. Just move like 0.05 millimeters on the y-axis. Put your camera on there.
Yeah, I wanted to have a dedicated setup and something that I don't know, could even carry around and place where I wanted to. So I made a prototype of a motorized mount, and then somebody helped me out and made a PCB for the ESP32 with the stepper motor driver. And somebody else helped me out to write a nice web interface which you can then use to control it to say, okay, go 1 millimeter of distance and to do like 300 shots. During this time.
That's not typically what you do on a camera slider. So my slider is like a meter long, and it's like, you do time lapse, right, on that. You don't typically. Oh, your image was frozen up for a while there.
Yeah, we'll also gone for a second.
You do time lapse over hours, and you get 1,000 images typically is what I do for a time lapse. You don't do just 1 millimeter very precisely. So ready-made hardware probably not the best choice for that.
Yeah, so I'm really looking forward to at some point kind of finish that project and to open source also the hardware for the camera slider, because it is cheap to make, and I think there are many people around who would have a lot of fun using such a system, and either for entertainment purposes or even for scientific purposes. I did really great pictures of filaments, and today I did a really nice macro shot of a cut up Revo nozzle, and just take a look at the internal surface finish and all of that stuff. And it's cheap if you know what you're doing, but getting started is kind of hard. And putting that into a video, I think there are going to be a couple of people who might enjoy that. Yeah,
not just in 3D printing, but just in general. Nice. I've thought about, so maybe one last comment. I've thought about like other ways of doing this, especially with a smaller microscope camera that actually fits onto a microscope. I've looked at just getting a regular microscope, and you typically have like the focus adjust dial, just motorizing that. Just putting the camera on there, using an actual microscope, and just motorizing that move up and down. Same idea, and I guess your hardware would work for that as well. With the ESP32. Just have a different motor mount. It'll totally work.
Yeah, definitely. I thought about buying a proper microscope exactly for such a purpose, but if you want to buy a proper microscope, it starts at $5,000, but then you're really getting just the very, very cheap stuff, or it's a special influencer price, or I don't know. In the end, I'm quite happy that I waited, because the results I'm now getting are really, really nice. And maybe even just one last comment. So with doing these individual images at different stages, you're getting in the end, during the image stacking process, a depth map of of the thing that you have been photographing. And since using a motorized camera slider, how big the distance was that you have been moving the camera slider between each step, you can you can use this setup to make really precise 3D scans, basically.
Yeah.
To figure out surface roughness.
If you have a scale reference in the image somewhere, or you know your scale if at a fixed focal length or focus distance, then and of course if it's an object that has some contrast to it or some surface texture, if it's just like a plain white ball, your image stacking software isn't going to be able to detect much in terms of features, and there's not going to be much stacking happening. But anything that has texture, even lathe marks or stuff on a nozzle, I mean, at that scale, you really see those. That's, reverse engineering that you can do with a camera. Nice.
Cool.
So one thing that didn't work out so well for you that you put in there is your Volcano
adapters.
We can't make a nice mix word out of that. Volcano adapters.
Volcano adapter. Volcodapters.
There you go.
This is basically nothing I really came up with, but I used in one of the recent videos just basically a thumb screw, which I drilled a hole through as a spacer to use a normal length or standard length V6 nozzle in a Volcano hot end. A grub screw. Yeah. Not thumb screw. Grub screw.
Oh, that'd be interesting too.
Because a Volcano nozzle is exactly 8.5 millimeters longer than a V6 nozzle. But some nozzles, for example, like the CHT nozzle from Bondtech, the high flow nozzle, is not available in that form factor. So you put that adapter in the middle, and then you can use any nozzle on a Volcano hot end.
And which I found you still get a flow advantage from using the longer Meltzone in the Volcano.
Exactly. Yeah. So get both. You have the flow advantage with the CHT nozzle and the flow advantage with like the longer heater zone. And there wasn't a product widely available. So there wasn't basically a product available. This was still a DIY solution. So we thought, let's just source a couple of these and put them into our shop. If people are interested in them, they can buy them. So we sourced a bunch of them. I sent them out to like 15 beta testers because I wanted to make sure that they are working before we're selling them. And after a couple of weeks, we got basically almost only positive feedback that everything was working, yada yada. And then we started selling them on our shop. And I don't know, there was some incident during the beta test where somebody said, this adapter somehow exploded in my hot end, and he didn't know why.
What?
Or he thought this was happening because he had a clog, and then he removed the adapter. He burned it out with a torch, and when he installed it again, it basically broke into pieces in his hot end.
Okay, well that sounds like you're like changing the material crystallization by heating it up that far. But
that's what we actually thought as well, because I wasn't able to replicate that at home. But I don't know. One night I woke up, which sounds really bad, and I thought, damn it. So what I usually do, even with my normal nozzles, I usually hot tighten them at maximum 250 degrees Celsius, because for once I usually don't often print that high. And if you're still like properly tightening a nozzle at 250 degrees Celsius, it will even not leak at 280 degrees Celsius. Exactly. And that's what I usually do. And that's what I also did with my Volcano adapter. And that's probably what all of the other testers did with their Volcano adapter. I don't know. I woke up and thought, damn it, what happened? Is the material maybe getting weaker if you would hot tighten it properly? So really heating your whole hot end up to 300 degrees Celsius and then doing the tightening process. So the next morning, screwed in the Volcano adapter, heated the hot end up to 280 degrees, tried to turn the hex key, and the adapter exploded in the hot end. It shattered.
Huh.
And yeah, I wasn't that happy at that point, because I think at that point we have already been like selling 50 orders. And
Right.
If everything works out, you are still able to remove the adapter quite easily out of the hot end.
But is this something that's happening like where the material grain is permanently changed if it ever gets to 280 degrees, or is this just while it is at that temperature?
It is just while it is at that temperature.
Okay.
So what I then did is I lowered the temperatures in steps and always tightened the adapter again, and noticed at 260 degrees Celsius it doesn't happen anymore. So
Okay.
I think at the point, so the strength of a material usually falls with temperature, but often the temperature and strength are not proportional over the whole temperature range. So in like the usual temperatures between like room temperature and maybe 200 degrees Celsius, it is quite linear. So you have a bit of a fall of the strength, but then depending on the material, at some point you get a really sharp transition, or the strength falls quite significantly. And it seems that the alloy that we have been using for the adapter, which is not the common alloy that many are using for nozzles, I'll come to that point in a second, seems to be weakening quite a bit at temperatures higher than 250 degrees Celsius. So in the end, what we did, we wrote an email with the investigation and what happened, and the recommendation to only tighten the nozzle at 240 degrees Celsius, which is usually fine for most of the materials. But it is just something where I thought again, okay, what amount of testing do you need to do in order to make sure that things like that are not happening?
Yeah. Well, it's beta testing. Essentially, you have to do it out in the wild. It's not something you can do yourself.
Yeah. So the reason why we chose a different brass alloy than like other brass parts is we wanted to make those parts out of a lead-free brass alloy. We talked about that already in one of the previous podcasts. So under REACH, lead is actually not really allowed anymore. There has been an exception that has been renewed over and over again, but we thought, okay, let's try to reduce or get rid of lead also in our product. So we said to the manufacturer, okay, please use an alloy that doesn't contain that. And it seems that this material is more susceptible at higher temperatures than the usual brass alloys that we're using.
Yeah. Well,
so
stuff
we try to make it right.
Out, right?
Yeah.
But just to be clear, this behavior that you suddenly get this weakening temperature. I mean, it's something you see in polymers with like the glass transition temperature. That's what that is. But it's only something that is happening for metals in alloys specifically, right? It's not like a pure aluminum or iron bar. It doesn't have that sharp fall off. It is literally just the alloy that is changing, and possibly specifically for brass alloys where it's that noticeable.
It is noticeable for, I would say, most engineering materials. Okay. But for this reason, there is a usual temperature range defined for like materials that we're using. For example, the usual brass alloy that is used for most brass parts, it has the sharp drop off at right around 300 degrees Celsius, which is also one of the reasons why we are only using our brass nozzles to 300 degrees Celsius, because after that point it significantly weakens.
So it's probably not going to shatter, but it might see accelerated wear, etc.
Exactly. Or you might break it off during hot tightening.
Yeah.
Could happen. Of
course.
Titanium 6-4, which is the most common titanium alloy, is... So if you, for example, look at a gas turbine or just a turbine of an airplane, there are different sections defined within that turbine which have different temperatures and what materials are used there. So, for example, Titanium 6-4 has a usable temperature range of, I think, up to 350 degrees Celsius, because up to that point, strength is totally fine. It gets lower a little bit, but at some point it just starts significantly weakening. And this is the same with other alloys. Sometimes the crystalline structure changes, but this does not necessarily have to be the case. And yeah, we kind of learned the hard way that the cadmium-free alloy that we have been using for our adapters,
cadmium-free, lead-free.
It's it's lead and cadmium free.
So wait, is there cadmium in the common brass alloys?
I think there can be traces of cadmium in the.
Wow. Okay.
Yeah. Not to the amount of lead, because lead is really put into that alloy on purpose to make it easier to work and things like that. But other heavy metals are still allowed up to a certain degree. Okay. So yeah, as I said, in the end, it just showed me that even in the future, we if we are like starting to sell products or getting products to the market, we need to make sure that we have a proper procedure to test the parts before they're getting released to a wider audience. I thought like shipping the adapters to 15 people might be sufficient, but it turns out that there was only, and maybe to close this up, when I found that out, I wrote this guy a message and asked him, hey, at what temperature do you hot tighten or did you tighten the adapter? And he said, yeah, I'm always doing that at 300 degrees Celsius. So I said, okay, yep, that was the case. And I spoke to a couple of others, and most of them said, yeah, they're also just doing it at lower temperatures.
Yeah.
So
do you know that joke with a product tester a QA engineer walks into a bar, orders a beer, orders 0 beers, orders 9,999 beers. Everything works. Then they put it into production, and the customer asks for the bathroom. The entire bar bursts to flames, killing everyone inside. That's kind of your situation right now, right? You have a use case that you couldn't anticipate, that you couldn't plan for, and yeah, that's what you need, like real life fuzzy testing for, basically.
Yeah. So, well, we could have. Of course, it was a bit of a mistake that I did. I should have thought about exactly that property, and I should have tried out to hot tighten the nozzle at those temperatures. I made print tests. I assembled them plenty of times. I did torque tests when they're failing, but nothing really did happen. But just temperature.
It's that one edge case that somebody's going to discover.
Yeah. And hopefully that's during beta testing. That's, I think, one of the reasons why this is really valuable.
Yeah. Or you just do it like, all the game devs right now, and you just do beta testing when you release it. Just say, hey, we're going to have a patch in a week.
Don't start me on that.
Okay.
I really like the new. So just one sentence. I really like the new Battlefield, and I'm still trying to play it kind of every day. It's a bit like an addiction, but it's barely even possible here in Europe anymore to find servers that are working. I think it's easier to play any Half-Life 1 mod at the moment in comparison to a game that has been released a couple of months ago. It's horrible.
Because it's just nobody playing them?
Matchmaking is not made anymore. Even though they're having bots, they're not able to fill servers anymore with people.
Okay.
I waited half an hour this afternoon to find a game, and it just didn't start. But
there's
different story.
There's no server browser in there anymore, right?
No, they did not implement that yet. After 3 months, we got a scoreboard.
That wasn't in the game?
No, there wasn't a scoreboard in the game, and the only thing that was released in a patch like after 3 months now was, we finally added a scoreboard, but nothing else.
I mean, I guess I can see why they wouldn't have it in the game in the first place, to reduce toxicity, etc. But
yes, just like they removed the dislike button on YouTube.
Exactly. That made the platform so much better. Okay. Yeah. Okay. Volcano adapters, beta testing. That's a lesson learned. Yeah. I don't know. I keep saying like I want to stay away from just releasing a product, a physical thing that I develop and put out there, because of stuff like this. Because there's so much overhead to like you think, oh, I've got this cool thing, I'm just going to put it out on the market, people are going to buy it. Not that easy. But it sounds like a fun challenge, and just
it is
just something
a learning experience.
Yeah, something new that you've not done before, right?
Yeah.
Oh, I don't know. One day, maybe.
One day.
How much more energy do we have for more topics?
Maybe just this one right here.
Okay.
Which is also, well, we talked about games just a second ago, and I received an email today from Quinley Vision. I'm already missing the words. Wordle for 3D printing. Which said, hey, do you want to try out your 3D printing skills? And we show you pictures of 3D printing fails, and you can classify these 3D printing failures, and we're gonna tell you how good you're stacking up against our AI, which might sound a little bit like, hey, either here's a cool game, or they want to advertise their AI for finding 3D printing errors. But the thing I directly noticed, I think really want to use the just like the word of those people playing the game, the work of the people who are playing this game, to use this as training data for the AI.
Yeah, well, 100%. I mean, would I guess so. So this isn't anything new, and we quickly touched on this before we started recording here, but this is something that, of course, Google has been doing with reCAPTCHA. That is exactly that. Google has also done Quick Draw a couple of years ago, where it's more game than Quinley Vision 3D Printle. So basically you sketch something out with your mouse, and the neural network tries to guess what you're trying to do, and by doing that you're also training it. Where was it going with this? Yes, so that's nothing new. And reCAPTCHA, actually, you can mess up a reCAPTCHA quite badly and it's still going to accept it as valid, because the AI itself isn't sure about what it's seeing either, or the neural network behind it isn't sure about it, and it's just taking your input to slowly learn. And if you're like close to what it thinks is correct, then yeah, it's still gonna let you pass. With something on a smaller scale, like the Quinley Vision 3D Printle, I would be worried about malicious users actually intentionally misclassifying stuff, because that can mess up your dataset quite badly, and you're gonna have to sift through all of those classifications made by folks manually again.
But I think this is one of the reasons why they are requiring signing up for that game. Because if there is one person who misclassifies everything, they can just throw, well, this person's training data out.
Right.
The interesting thing is that we talked kind of exactly about that 2 podcast episodes ago or something like that, where we talked about an idea to use AI to identify 3D printing problems on a final part, where we said, okay, this could be done, but you need to train that artificial intelligence in a way. So you need a lot of pictures of failed parts, and then really people marking areas on the parts and saying, okay, this is a layer shift. This is, I don't know, a loose x-axis. This is under extrusion. 3D Printle is using an AI approach to find errors during the printing process, but also for training the AI in the first place, they need training data. And I, even though it's sneaky and they're not saying explicitly on the website, at least what I have found, that they will be using, or their main purpose for that is using that for training data for their AI. I'm like 100% sure that this is the primary reason why they're making that. And in some way, I'm not really blaming them for them, because I think it's a good idea.
Sure. Yeah, so of course we've seen the sort of machine vision print failure detection, of course, Spaghetti Detective. The big guys there. But there are others too that do this sort of monitoring. The name eludes me. I can't remember the names right now, but I think there's like at least two others that do that same sort of like real time tracking and print abortion if stuff goes wrong. But like I said, you need training data, so everyone who's already in the game is going to have a head start, because all the prints that people do through those systems, those are also going to be input as more training data. So that the longer you've been around, the better you are.
Yeah. And in order to train an AI, you need a ton of data. What Google did, and I'm not sure, I don't know if they actually came up with reCAPTCHA or they bought reCAPTCHA at some point. They bought them. This was one of, I think, the greatest ideas ever, because I don't know how many million hours every day were spent on, in the beginning, just trying to interpret text which was scanned from a book. And they have been using that to make it possible for AI to perfectly read even the brokenest of texts. And having this free work, or getting this free work with a game, I don't know if many will do that. I have not signed up yet to the service to try it out, if it even works, and how fun the game is in the end, and if it's the Wordle of 3D printing. But
I mean, so calling it the Wordle of 3D printing is sorry, but that's BS. That's I mean, I've played like 3 rounds of Wordle. That's nothing like it. There's no combination, no guessing, no thinking involved with the with what are they calling 3D printle. It's Wordle used to be popular. Everyone knows it, so like easy click.
I've never played it.
Like I said, I played like 3 rounds of it, and then I was sick of it and just muted the word on Twitter. So I don't know if it's still around, but it doesn't exist in my world anymore.
I guess it's not that popular anymore. Yeah, so that's it. Shall we answer the last question?
Yes, let's do that. I keep stretching my shoulder.
Yeah, no worries. A quick one. So, Groyan is asking, considering a failed thermistor on the Revo, basically why we are still using thermistors on our hot ends and why we are not using thermocouples, because they are more reliable and they are more precise.
Because it's good enough.
Yeah, Tom says it's good enough. A thermistor, which is just a resistor that changes its resistance over a temperature range, can be read out quite easily with just a normal microcontroller and no really additional active components. A thermocouple already requires an op-amp. Op-amp.
Yeah, well, or an amplifier.
An amplifier.
It's usually like high sensitivity amplifiers, basically, because the voltage the voltage difference generated is relatively small. So you need like low noise amplifiers, and those parts aren't that expensive, like the 711. But it's an extra component. And the thing is, thermistors work well enough, but also they work on literally every single machine that's out there, except maybe an Ultimaker. Or machines, proprietary machines that are built with that. But every like open machine has thermistor circuitry on there. So the choice of using a thermistor in Revo, where there is right now one single heater core, well, two single heater cores. There is that special one for the Creality machines with a different thermistor in there. But
there is?
Yes. So
does it have?
It has a different
Okay.
the Creality one has a different thermistor that is like plug and play compatible with Creality machines.
That's cool.
The standard Revo is plug and play compatible with every machine that expects a V6. But yeah, because there is only those two those two cores, like I guess adding more variants to them, especially right now at the start for launch, is not something they wanted to do. Maybe eventually down the road there might be a high temperature version of the Revo heater core that has a thermocouple in there. But yeah, I mean, we've already seen how bare bones the Revo ecosystem is with, 4 nozzles, 1 heater, 2 heater cores, at least at launch, and the couple heatsinks that they have. It's not something that they've like flared out as much yet. So maybe it's going to be there, but the obvious choice for launch, especially, is using a thermistor. And
yeah, because it also works up to 250 degrees Celsius, totally, very reliably. 300 degrees Celsius, even that is not a problem at all.
I think they are rated for 300 officially, yeah.
And currently we are only seeing thermocouples on machines or on hot ends, which can be used up to higher temperatures, which are used for printing, I don't know, PI, peak, something like that. But since it is so simple, I guess that's in the end one of the reasons why it is so commonly used.
Yeah. So is it maybe a bit of a chicken and egg problem that we're not having hot ends that can print that hot, so we're not getting materials that need to be printed that hot, so we don't have a demand for hot ends that entire thing. Is there even a material that like isn't crazy expensive, like PI, PEK, that group that would make sense to be printed in a 3D print? I mean, metals you can't really print; they just get runny. Or brittle. So that dream, sorry, is probably not going to happen. But polymer-wise, I don't know, maybe printing like glass, like actual glass, that could be something. But yeah, I don't know if there's even a need for a high temperature.
Yeah, I don't. Well, maybe there is a need because there are, I think, plenty of applications where you would need, for example, higher temperature resistance. I think in the end, this is also a chicken and egg problem, or this is a problem of economy of scale. If there aren't a lot of printers around that can print high temp materials that need to be printed at these higher temperatures, there isn't a lot of demand, so it's not manufactured that much, so it is expensive. I'm quite sure if PEEK would be the 3D printing material that everyone is using, a kilo wouldn't cost $500, but you would be easily able to get it for $100 or something like that.
Okay, yeah. Well, I was thinking we're going to go for like, we're $20 a kilogram, no problem. Nah, it's still going to be an expensive material.
Yeah, of course.
And yeah, it's still going to be an expensive material. So I don't know. There might be a thermocouple version of Revo at some point. There might be a high temperature one. Maybe once Obsidian is out. Do you know that should be temperature resistant, right?
I think it's copper that's coated with diamond-like carbon. I don't know, a lot of different coatings to make it wear resistant. So it should be capable of handling these high temperatures.
Here's the problem. I don't know what information I'm thinking about right now is like NDA'd and what isn't. Okay, but yeah. So Obsidian technically is going to be high temperature material. So like, yeah, it's that would be, I guess that would be the time to release a high temperature version.
Yeah. So I don't have any information on Obsidian yet. I know it only from I don't know, the things that they talked about at Formnext, but I'm really hoping that it's gonna release at some point, because I think the Revo ecosystem is still missing that. And yeah, maybe at that point also we get a higher temperature heater core. We will see. The question, maybe last point right here. So you did the analysis of the PTC positive temperature coefficient, PTC heating element of the Revo.
Right. Yeah.
The problem might be, of course, yours still got to 450 degrees Celsius,
80.
but for 80, but the PTC element is having a lower PTC element is having a lower power output at higher temperatures if they would even need to change like the heating element that they're using to easier get to these higher temperatures.
Quite possibly, yeah.
Yeah.
Yeah, if you combine it with a thermocouple, I'm very sure that either they'd reduce the PTC effect of the material, or they just put a higher power one in there.
Yeah,
shouldn't be that hard. So what I was trying to find out here with Obsidian is whether there is a pressed in slug in there.
I don't think so.
Because there are images of the old Obsidian that look like they have some sort of a slug.
Okay.
But I don't know if the new one still does.
Josh explains. I'm really missing. Yeah. I see what you mean. It looks as if there's something pressed in, but the whole nozzle bit seems to be... Yeah. I don't know. We'll see. I'm really looking forward to getting more details on these.
Yeah, because that's supposed to be the end-all nozzle, essentially.
I hope it performs well. I think if they're using a well thermally conductive material as a base material, and I think I heard it is, I don't know, don't quote me on that. Copper, I think it gets around the downsides of the Nozzle X, which is using steel for that. So we'll see.
We will see, yeah. One way or another. And one way or another, I think we are done for today. We skipped over one topic, but that's something for the next one. So get subscribed on all the platforms where you can subscribe. Of course, if you're watching on YouTube, if you just want the audio version, you can listen to us too on any podcasting platform. If you're listening and you would like to see Stefan's beautiful face, then you can do that on YouTube. The Meltzone channel is available there with a full video capture of us recording this episode. What else? If you want to support our channels, you can do so through Patreon or YouTube memberships on the main channels. Links are in the description below. Also, links to all the stuff we talked about are in the description or the podcast show notes in your player as well. Thank you all for watching and listening. Thank you, Stefan, for the time.
Thank you for yours. See you in the next one.
See you then. Bye.
Bye-bye.